The hydraulic press reaches position. The tooling opens. The part comes out, and then the metal decides it has other plans. That movement is called springback, and it can affect everything from a simple formed panel to a complex aerospace or automotive component. During forming, some of the material is permanently reshaped, but some of the deformation remains elastic. While the part is held between the dies, that elastic energy is still trapped in the material. Once the press releases the load, the material partially recovers toward its original shape. That recovery is springback. The amount of springback depends heavily on the material. High-strength steels, aluminum alloys, titanium, and other advanced materials generally produce more elastic recovery than softer materials. Thickness, hardness, grain direction, and even variation between material batches can also affect the final result. Part geometry matters too. Tight radii, shallow contours, long flanges, and complex shapes can create uneven stress throughout the component. In deep drawing, die forming, stretch forming, and straightening, different areas of the same part may recover by different amounts after the tooling opens. So how do manufacturers compensate? One method is overforming. The tooling intentionally moves the material beyond the required final geometry. When the load is released and the material springs back, it settles closer to the intended shape. The required compensation depends on the material, tooling, geometry, temperature, and forming sequence. Tooling design also plays a major role. Die radii, draw beads, binder pressure, cushions, restrike operations, and calibration stages can all help manage material flow and redistribute stress. In hot forming applications, heating the material can reduce its forming strength and limit springback, particularly with difficult alloys. Hydraulic presses provide another important advantage: precise control over the forming cycle. Ram position, speed, force, dwell, cushion pressure, and motion profiles can be programmed and repeated from one cycle to the next. Holding the part under pressure does not automatically eliminate springback, but a controlled and repeatable process makes it much easier to predict and compensate for. Measurement and simulation can take that control further. Laser scanning, dimensional inspection, and forming simulation help engineers compare the intended geometry with the shape the part actually reaches after unloading. That data can then be used to refine the tooling or adjust the press cycle. Springback cannot always be eliminated, but with the right tooling, overforming strategy, temperature, press controls, and inspection process, it can be engineered around. Because the shape of the part under full hydraulic pressure is not the shape that matters. The shape it keeps after the tooling opens is.